kind of funny. I'm used to like seeing karaoke up here, not being up here presenting, but I won't sing. Don't worry, you wouldn't want to see it or hear it. Yeah, my name is Hoff. I'm a senior solutions engineer with Talend. Been with Talend for about 5.5 years, and actually support Bill. So when he talks to prospects, I show him software, or I show them the software, demo software, different things like that. Again, thank you very much for being here tonight, giving me the opportunity to talk to you. And so, first of all, I just want to ask, because we're talking about IoT, Internet of Things, and big data, Spark, and all that, I'll be covering tonight. Just raise a hand for showing people that have been dealing with big data and Spark in their jobs and in real life. Wow. Okay. Very, very small. Very few people here on that. So, with your raise a hand, just let me know who understands or who knows what big data is, and IoT, Spark, and all that. Don't be shy, because I just want to make sure everybody's kind of on the same level here to understand what I'm talking about. Because I, get off, start talking about things, and you're totally lost. That's just kind of a waste of your time and my time. Okay, so I'll just step back real quick and just kind of explain. We'll talk about big data. What that really means. Big data is, to me, it's more of a marketing term. Big data is what it's talking about. Big data. It's a lot of data. So you can imagine these days, just with banks, the number of millions and millions of transactions that banks have to deal with every day. Your ATM, writing checks, different things like that. Credit cards. All that information has to be tracked and stored somewhere. Okay, so the big data is basically taking that data and putting it somewhere. Okay, that's one part of it. All right, so that's just storing the data. But stored data is just stored data. It's useless. All right, so you have to be able to do something with that data. Okay, so that's when we get into talking about your analytics. I'm talking about, and I'll get into this in just a second, but I'm talking mostly about data science and machine learning tonight. And so that's what that's dealing with. You have to be able to take this data, do something with it, predict what's going to happen in the future based on this data. And then IoT, what that stands for is the Internet of Things. Okay, Internet of Things means basically getting data from everywhere. A lot of us dealing with sensors. So these days, if you have new cars, all these cars have sensors for basically everything on your car, your engine, just everything in there. So that's tracking data. A lot of these cars, you'll actually send this data back to the company, and you can get monthly reports on the status of your car. Does it need to go into maintenance? There's something wrong with your car. Now, I'm sure everybody now has a little light that goes off that says something's wrong with your car. You can't do anything about it, right? You have to go take it in. That's just all dealing with sensors. So is that what the Internet of Things is all about? Is this data just coming from everywhere, doing something with this data, analyzing this data. All right, so that's what the kind of big data is about. And then you have really different levels. So you have the storage level, which HDFS is kind of one main role in that. HDFS is just the Hadoop file system. It's really equivalent to a flat file. So if you're used to seeing data stored in a flat file, it's really the same thing, but it's just stored in the Hadoop environment. So Hadoop's kind of the big data environment. You can almost see it as maybe as an OS. It's just another server where your data is stored. You have HDFS or data stored. You got something called Kafka, and I'll be demonstrating Kafka today. That's just a queuing system. So if you've heard of different queuing systems, it's basically taking data, loading it into this queue that can be read out in real time. Real-time processing as opposed to batch processing. And then you have Spark. So Spark's really just an engine that is used to process this data. So it takes the data, it distributes the data across multiple processors. So some of these companies might have thousands of processors. And so what this Spark does, it takes this process, puts that data and process across thousands of these clusters, does its transactional processing, brings it all back together so it can increase performance tremendously. Okay, so I hope that's at least a little bit high level, to at least give you, on the same level here. We'll go ahead and get talking here. So, I've mentioned data science. So these days, data science and machine learning is really becoming very, very important to these companies that are moving from your basically your batch historical analytics. So it's really you looking at the data and going, okay, this is the data, and maybe some historical data, and saying that, this is what the data shows. Okay, that's all you're getting out of it. What the data shows, what's happening right now. And then moving on to the predictive analytics. So taking this data and being able to act upon it. So really saying, okay, I have this data, so now I can predict what's going to happen in the future. And that gives you the capability to really act on that data. And then it's actually turning more into what's called prescriptive analytics now, which is basically not just analyzing the data and predicting, but it's also giving you multiple choices on what your action can be and kind of the risk associated with that. So as we get into this analytics that are really necessary, this type of technology becomes very important. And so nowadays, the data scientists and the machine learning people that are writing all these, they kind of sit on their ivory tower, doing their things, and they are kind of worship. Nowadays, the companies need to be more data driven. So data driven meaning you need to take your data, analyze it, and do something with that. With that, more companies need these data scientists to really be available to everyone. So they need to be able to look at all the data, predict what's going to happen, and give that to everybody across the whole enterprise. So as I mentioned, big data is just a lot of data. You can I don't know if you know the you've heard megabyte, gigabyte, terabyte, petabyte. So it's getting higher and higher. You're talking billions and billions of records. And without these data science and machine learning process, data is it's really just data. It's really useless unless you can do something with it. And big data can be used for many different things. We've seen a lot of this today. So one of the things is for dynamic pricing. So if you're on a website, sometimes they will maybe change the price based on your actions. We actually have a customer called Auto Group, which is the Amazon equivalent in Europe, that they use big data and real-time processing in our software to predict when somebody is going to basically drop their cart. So you're shopping on Amazon, you're there for a little while, and then you get bored or change your mind, and you just kind of abandon your cart. Well, they've come up with models to predict if somebody's going to abandon their cart, and they have will go out there and maybe offer a 10% discount, bring it back in, and just by a 1% increase or decrease in the people abandoning their carts, they have saved millions of dollars, or made millions of dollars. You also get the product recommendations, and I'm sure you've all seen this. You go on Amazon, you look up something, and then you get other products that are recommended to you. And the scary thing about it is you'll go back over to, obviously, sometimes go back over to Facebook, and there's an advertisement for that product I just looked at, right? Or Skype or iHeart. It's like all over the place. So that's all big data, real-time processing that's doing that behind the scenes. And the last one is predictive maintenance. So we have a customer, GE, that is using, again, big data, real-time processing to look at their wind turbines and get find out ahead of time when these wind turbines need maintenance. So they're not down for a month, or it's in such bad shape that they just fall apart. I've seen videos of a wind turbine just basically just exploding. So GE uses big data and real-time processing for that. So it's it's really used in a lot of different cases. Skip my slide 2, but that's all we can talk about this. So slide 2 is just basically talking about basically bringing the data science or scientist processes together with IT. So data scientists, they're the ones going out there creating these models for these analytics. It's very complicated. They have different types of models out there that you can create to predict what's going to happen with your data. And So the data scientists out there writing code in Python or Spark, using these data science tools to do all this. And they're really good at that, but what they need help with is being able to make it scalable and to productionize it. And so that's where IT gets involved. And IT, they're the ones doing the programming. A lot of IT have a lot of the ETL development tools, such as Talend. That's what we do is data integration ETL. And so they're bringing these jobs together, productionizing these jobs using what's called continuous integration to be able to quickly make changes to the code, push it out there, test it, get it in production. So very quick process. But there's really a big gap between the data scientists and the IT in a lot of places. They just they kind of talk two different languages. That's kind of like the gap between IT and business people sometimes. There's just a gap there between the language that they speak. So you need to be able to somehow bring that gap together. And that's what this slide is showing here. So you have your data scientists that again that are coming up with the processes, the models, and all that, and IT that's going to help them by bringing all this together with continuous integration, which again quickly taking their request, turning it into jobs that they can productionize. And Talend is helps bridge that gap between the two. Now this is not all on Talend. This is more on big data, Spark, and all that. At the end, if you have questions regarding Talend, I could definitely cover them with that. So here's an example of how sensors are used in the airplane industry to help with maintenance. So this is an Airbus 380, Air France, and there's over 300,000 sensors on this airplane. Okay, so you can just imagine the amount of data that's being sent for that. The fuel system is obviously very important. You need to track that. So there's like 24,000 sensors just on the fuel system itself. So these sensors are used to be able to predict when maintenance needs to be done on an airplane. And so every time the airplane lands, it's going to, using Wi-Fi, it's going to send all this information back to headquarters. And I think it says on here, there's 1.6 gig of data per flight. So you can imagine for all the airplanes that are out there, when they land, send 1.6 gig of data. That's a lot of data over time. Okay, so what they do is they take that data, compare it with historical data, and then they can tell based on the sensors, looking at that, if it needs maintenance. So instead of waiting till you're on the tarmac and get the little light come on saying, oh, we've got a maintenance problem, sitting in the tarmac for 2 or 3 hours, they can take care of this maintenance ahead of time. So fix these planes ahead of time so there's no bad customer service or customer satisfaction. So that's one example of how sensors are used in real time. All right, so now let's get to the interesting stuff. All right, so I am going to actually have a demonstration today. And so what I'm going to be showing you is a demonstration of analyzing real-time image data for performance measurements in the EPS. EPL is the Europe Professional League, so it's Europe soccer. Football over there, we call it soccer. All right, so it's just going to be a simulation of that. So, so the first question is, so what? Why? Why would I, want to even show this? All right. So first of all, it's it is a fun example, but there are real life reasons or real life uses for this big data and its analysis. So we'll talk about manufacturing. So most of the car dealership, car people out there, they when you're manufacturing vehicles, you have the robotics. And so those have sensors in them because something goes wrong with your robot, you obviously want to know about it as soon as possible. If you spend all day with something out of sync with a robot, that's all going to cause a lot of problems. And then you have a lot of cities that are now using sensors to analyze the traffic and to control the traffic. So the wreck over here, they'll know about it. They can send traffic somewhere else. Signals are out, different things like that. And then the mechanical data from aircraft, I already showed that with the previous slide. And sensors are everywhere. The IoT is definitely everywhere. Let's get back to our sports thing. And this is really amazing stats here. So the UK office collects 1.3 billion pounds of taxes just from the professional sports teams. That's like what, $2 billion in the US. That is a lot of money. So significant money there, for soccer. I mean, we know that. You see it, and over here in the NFL, same thing, very popular. Sadly, that's like greater than the GDP of the bottom 25% of the country. So huge monies. And then here's more of the U.S. statistics. So we have $95 billion wagered annually on NFL college games. That's a lot of money. I don't know where I'm getting all this money, but I like some of it. And then that's, if this were a real company, this would be the number one on Forbes 2000 list of companies. If all the gambling and all that money was like one company. All right. So anyway, well, let's just talk about what we're going to demo today. So we're going to show you, and this is really pretty impressive too. You've probably seen this. Is, nowadays with the advanced technologies with cameras and other things that for a lot of the sporting events, they have these cameras that are positioned all over the fields, and they're tracking all the players' movements, as well as the balls and things like that. So they have these arrays of cameras to capture the balls and the positions live. So the NBA, they've been doing it since 2011, 2012. And they have tennis that's been doing it, as well as soccer over in the UK. And I don't know if you've seen this, but I've seen this a few times when they're doing analysis of like NFL football games. They'll actually show where the quarterback throws the ball, and they'll actually have a tracking on the ball. So it'll show how far it went, 35 yards, this trajectory. It's just amazing. So all this stuff is being tracked, that way. And also I've seen them show the speed of the runner, 15 miles per hour, football player running down the field. So all this stuff is being tracked in real time, and all this information is being sent out in real time to be processed and analyzed. So our goal here is to aggregate the speed and distance run of each player in real time. And so we want to see how fast they're going, how far they're going. So we've got our fast players up here, and I play soccer, so that's probably me over there on the backside, the slow old guy. Okay, but that's really what we're going to be showing in the demo today. Right? The challenge here is taking all this data and being able to process it. So in the simulation, these cameras, they can actually send a feed of 25 frames per second. So that's a lot of data. Each frame contains the X, Y, and Z coordinates of every player, and that's being sent out all the time. So that is a tremendous amount of data that has to be analyzed. So here is the demo architecture, what I'm going to show. So first of all, we have the ingestion. So we have the data that's being fed from the cameras, and here that shows JSON format. So I don't know if you know what JSON is. So you have just different formats of data. So I don't know if you've heard of XML, but it's just a structure of data. It's more free form than flat files or relational databases, and it allows you to really build some very complex hierarchies in the data, and it's just a very quick and easy data structure to process. And so we're going to take that data and we're going to feed it into the Kafka. So again, Kafka is just a queuing system. So it's going to take this data, feed it to this queuing system, and it's going to sit there and wait for something else to grab it and do something with it. So that's where Spark streaming comes in. So Spark, again, is just let's just say, look at it as a processor. So it's just processing that data. And then Spark streaming just does it in real time. And then we're actually storing the data in a database, and then we're delivering the data using HTTP, so basically sending it out to a website. And we're going to display that data, or visualize that data in the website. All right, so all these processes are going to be done using the Talend software. All right, so now I'm going to switch. Yes?
Are any of those components shown in that graph MQTT brokers at all?
Are they MQ brokers?
MQTT brokers?
Don't think so.
Okay.
give me half a second. I just realized before I got here that I need to be signed into a Wi-Fi, so I need to connect to my phone real quick. Should be connected now. All right, so now I have switched over into the Talend Studio. So the Talend Studio is a development environment. So it's a drag and drop interface. If you've ever used your Informatica or Data Stage or any of those, it's very similar to that. It's a drag and drop interface. Sorry. And in the background, it's actually generating code. So we generate Java code. If we're running in the big data environment, then we generate Java code as well as Spark code. Code generator. Now what I'm showing you today is just basically some of the components that we have to be able to run through this process. So in the previous slide I mentioned the Kafka, so this component called Kafka input. So that's just basically reading data from Kafka, and then we're doing a lot of different processing here. And then in the end we're actually writing this data out to this MySQL. So our actual target database is MySQL. In this case, it could be any database. We support most of the databases that are out there, or MySQL, SQL Server, anything that's on Hadoop, so Hive, everything like that. And so I'm going to go ahead and just run this job. Now you can run locally, which is what I'm doing now, but you also take these jobs and you can move them into your production environment. Okay, so we're not an engine, we're a Java code generator. Take the code, move it to your production environment, run it there using our schedule, So I'm going to run this job. And what this job is reading the data out of the Kafka queue, and it's pushing it out to MySQL. And the next job I'm going to run is actually going to read that from MySQL, and it's going to update a website. So here I'm using a REST component. So we have components that allow you to use REST to talk to APIs, to push data out to APIs, and get data back. So that's what this job is doing.
Are we supposed to be seeing it?
Yes, you are.
Well, it looks incredibly impressive.
Why did it take you that long to say something? I don't know why.
I was enjoying the anticipation.
All right, let me see here. I might have to just minimize this. That screen. That did it.
Follow us, Bill.
There we go. All right, I apologize for that. Thank you for pointing that out. All right, so go back to here. So this again is the Talend Studio, and it's basically drag and drop. So you have a lot of components that you drag in the job and connect them. So here I have the Kafka input. So I'm just reading data from the Kafka queue. I'm doing a lot of processing down here, and then I'm actually writing this out to MySQL. The MySQL output. But as I mentioned, we can write out to many different kinds of outputs. And then from here, I'm running this job that is reading data. I'm sorry, it's taking the data and it's pushing it out to an API, which is basically a web service. And then from there, we should be able to see the results. I'm going to switch over here. All right, so these are the results. So this is showing in real time. So again, we're simulating the feed. So we're getting the feed every 10 seconds of all the player data coming in. And we're processing that, and we're putting the results out to the web. And so this shows the speed and the distance of the different players. So it should update every 10 seconds. And then down here, it'll actually show, for each player, the different speeds and distances, different things like that. Okay, so again, just an example of how you can take real data, do some processing on the data, analyze the data, and then show the results. So in this case, we're just showing results of the speed of the players. Yes?
You could just talk a little bit about the Kafka endpoint. Is that just a publicly or an available API that's always listening for data and is listening for data in a JSON format, or?
Correct.
Okay.
Right. So in my job, to go back to my so here in this Kafka component, so every Kafka, or sorry, every component has a component tab associated with it. We put in the parameters, and so here I'm telling it the broker list. So this is basically the API for it. So I pointed that API, and then I have what's called a topic name. So I have this. I have actually a context. Context is just a variable that I pass in. I can pass in at runtime with a value. So Kafka has what's called topics, and so it's like a category. So you can put things in different topics, and then you pull the data out of that topic. So it's just passing it in. It doesn't have to be JSON. It can be any type of document you want. You can pass a flat file out there, but you just pass the data out there. It's sitting there, and then you have a process to read it in, and then do something with that data. Did I answer your question?
Mm-hmm.
Okay. All right, so from here, after you have, you see all the results, then, basically the next step is, go back to my PowerPoint, is kind of what do you do from here? Let's see if this will come up. So what do you do from here? So we basically took the data and analyzed the data. Okay, we showed the results, good information, but from there, that's when you have to do the modeling and do the predictive analysis to figure out what to do next. So who, for the team stats, and who's most likely to score next, or who's going to win the game. So who's going to win the game is obviously very important to the bettors out there, right? So that's good information to have. And then for the individual stats, it's who needs to be sitting down for a while. So you look at the stats and going, okay, this person might get a little slow right now, so we need to maybe sit him out for a while. Then who might need to be traded. Looking at historical data, they're taking that information, comparing it to current data. This person has just really gone downhill the last 3 years compared to the previous 5 years. Maybe it's time to trade that person. So again, the whole idea of this data science and modeling is just to be able to take the data, do predictive analysis on that data, and make smart decisions based on that. And then, so here's 5 steps to become fully data driven. And again, what I mean by data driven is taking that data and making it useful. That's these days that's very important for companies, because with all the competition out there for in every industry, you need to be smart with your data. You need to be able to predict what's going to happen in the future. So step 1 is access to everything. A few years ago, before big data came out, we had our data warehouses, and you could put a lot of data in there, but unless you have just a huge machine, huge processing, there's only so much data that you can actually go back and look at. Historical data, maybe you can only go back a month, depending on what you want to do with that data. Sometimes maybe even a week. And in this day, that's just not good. So with big data, now you have access to everything. So you can just dump all this data into the Hadoop clusters and then be able to analyze it. So you have access to everything. And the collaboration. Again, as I mentioned earlier, you have your data scientists and you have your IT people. So they have to be able to collaborate to bring these systems together to make them enterprise-wide and available, and do that using continuous delivery. So as things change quickly, you need your IT people to be able to make those changes, put those changes into production, push those back out to your data scientists. And very important, and combine historical and new data. So if you have just historical data, obviously that's not going to give you everything you need, and just new data does either. So you have to be able to combine it all, which kind of goes back to the first step there, access to everything. You have to have access to all this data, combine it all together to be able to make intelligent decisions. And you have to have the capability to run in batch and real time. Used to, years ago, everything was batch. When I started COBOL, that kind of aged me right there. But everything was batch. I mean, real time wasn't even known back then. Right? So you had your batch processes that run, every night, 1 to 12 hours. Data comes out next day. You're good to go. But now you need to have both batch and real time. You need to have also the data quality capability that's intertwined with all that. It's bad data going in and bad data going out. The data quality is what sit on top of all these processes.
I have to ask, what do you have planned for the 6th Lego?
6 Lego? That's the goal. So our goal is insights and value
sorry.
into the data. So this is
Stole your thunder.
Inquiring minds want to know.
So that's our goal. So to do this, insights and value out of your data, you have to be able to have these 5 steps for that. And so just a little Talend promotion here. So what I was showing you earlier with the Talend jobs and all that, that's in we call it our Talend Big Data Sandbox. So you can actually go out to our website, talend.com, very simple, and download that. So it's a virtual machine that you can either download on Cloudera or Hortonworks on. If you don't want to download, it'll do it itself. And it has the studio also installed on. And that job that I showed you with the sports analysis, that's also, there's actually 4 other demos on their own site. So if you're interested in, not necessarily Talend, but just interested in understanding and be able to use big data or Hadoop, you go out there and download it from our website. And that's the end of my presentation. I will stop here and let you ask any questions and then turn it back over to Dave. Yes, sir.
How accurate is the predictions that it makes?
Well, it really depends on which model. There's multiple models out there, and I'm not that familiar with the models. They are very complex. I've looked at a couple of them in our software. I don't have a clue, but they are very accurate. Again, that's where a lot of these companies, the data scientists, they use these different models, and like Java has different model classes, or Spark has different models, processes that you call. So it's already kind of a predefined model. So it's not like you're building a whole model. You're using these model processes that are already built to give you this analysis.
Yeah, but like with a game, if it's a 50-50 game and you can win 51% of the time, I mean, that can make you a lot of money with the $98 billion out there. But does it get up to 60, 70, or even 80% predictivity, or?
Well, I can't give you a number, but the more data you have, the more accurate it's going to be, right? I don't know if you play fantasy football.
Nope.
I know a lot of people do. I don't, just because I don't have time to go through and analyze all the players. I've got a few teams I like, but I don't keep up with it. But these days, you can actually go in and they just have so much analysis they provide to you on these players. They can actually kind of pick the team for you based on statistics in the past and kind of what they're going to do in the future. So it's really based more on the amount of data that you have, and then the type of modeling tool that you're using.
Okay.
But I agree with you. Yeah, if you can get 80% as opposed to 51%, obviously you're going to do much better. We're not a gambling tool. Yes.
So you just touched on something that brought up the question. Are you guys providing the algorithms themselves, the rules, or do you provide the sandbox that allows somebody else to develop the rules to leverage the data?
No, so we provide both.
Okay.
We provide the rules. So the sandbox is just, really, it's just a playground.
Yeah.
Just so people can use, Hadoop and CL software. But we do have components. I'll show you that Kafka component. We do have components that are modeling components. So you drag and drop that component into your job, and it's a specific type of model that will do what it's supposed to do. Yeah, so we provide that.
But at the same token, if I'm a smart algorithm guy and I want to create my own algorithms leveraging the data that you're storing, I could do that too.
You could, and you could take your process that you've written and embed it into our tool. Because the really point of our tool is to be able to take these jobs and productionize them, make them enterprise-wide embeddable.
Okay, thank you.
You're welcome. Yes?
How's the data going from Kafka to Spark? Is Kafka calling a Spark process or Spark pulling the data from Kafka?
Well, so in the job that I showed you, you don't see it because Spark's really it's not a database or a data flow. It's more of an engine. So it's really just sitting underneath the covers, and it's a Spark job. Okay, so when it generates the code, it's generating Spark streaming code using the Spark streaming infrastructure. So let's just back up and just say we're just doing straight Java. So you're going relational to relational. Okay, it's just going to generate straight Java code. All right, now once I move into the Spark streaming environment, now it's just going to generate a Spark streaming code. Does that make sense?
Yeah.
All right, so you're really not, you are feeding the data through Spark because it's the processor, but you're not defining a Spark component per se to do that. Spark's more the infrastructure. Yes?
Does Talend Spark have anything at all to do with Sun Spark?
What Spark?
Sun
No, what's the
Microsystems?
first one?
Talend Spark?
No, so Talend Spark, there's not a Talend Spark.
Oh, okay.
Talend supports the Spark environment.
It's
Okay.
Apache.
All right, so we
Oh,
run,
okay.
so Talend runs naturally, natively in these environments. So it runs natively in Hadoop using Spark. It runs natively in Hadoop using MapReduce. So we just generate that code. We don't have our own Spark. And we're called open source. So we basically work with Apache and work with all these different open source products.
Cool, thank you.
Yes.
You mentioned that you're open source. Do you release the source code for your products or like the software, the sandbox environment out there, or do you work with open source products?
The actual source for our product, I don't know if we release that. I think it might be available contractually, if you know what I mean. But
Yeah.
The actual code itself, like when you that job I showed you, you can see that code. So that code's there.
All right.
All right. So because what you do is you actually take that code and you want to move that code to your production server, and you're going to run that code there. All right. So
All right.
the actual generated code, you can see that. We're not a black box. You can see everything that's generated. In the back, on the right.
Yeah, so the data visualization part, like the data, the graph that you showed for the demo, was it pulled from the SPFS file system or was it pulled from MySQL database? The every 10 seconds refresh of the data, where does it come from?
So where does the data come from?
Is it from MySQL database or from the Hadoop
No,
file
so
system?
the original data was loaded from a JSON file. I didn't show you that job. I did some preloading. So the original data was loaded from a JSON file into the Kafka queue. And then what I showed you was reading the data out of the Kafka queue, and then the final step of that was loading that data into MySQL.
Okay. So my question is, why do you have to go to MySQL instead of pulling it directly from the Hadoop file system itself?
You don't have to go to MySQL. This is just an example.
Okay.
You can pull it directly from Hadoop. I could have loaded that directly into Hadoop. All right, but just for this example, we decided to load it into MySQL. Yeah, so we can load directly into HDFS or HBase or any of those, read out of there. MongoDB, we support all that. Question over here?
Yeah, I have questions related to the SQL server.
So related to what?
Using the SQL server, right? The SQL server. You say you are storing the data in SQL server, or you are storing
SQL server.
MySQL.
MySQL.
SQL server, or you are storing the data in the HDFS?
No, so we're actually storing the data, in this case, in MySQL.
Okay. why you guys not choose a Cassandra or HBase to storing the data?
It's just an example. We could have very easily loaded to HBase or HDFS. I didn't write the demo, so.
Okay.
But no, we could have very easily gone to either one of those. We support all that.
Okay.
Yes?
So I think the point of what you're trying to show was kind of this like drag and drop ability to create these workflows, and you kind of went from like the data capture to directly to the modeling process, but are there components? So like in data science, you rarely move right into the modeling without doing some kind of processing or transforming of the data. Are there like components meant to like implement your customized transformations of the data?
Yes, I didn't even show you the whole job because I didn't want to scare you. But that job has probably 10 or 15 components in it. So we have many different types of processing components. So we have like a T-map that's used for your mapping, transformations, different things like that. We have aggregation, sorting. So yeah, we have over 900 components that come with our software. So it's definitely a lot of capability out there. Yes?
So, what is the average time to develop that type of application, end-to-end application?
What's up, sorry?
What is the average time to develop that type of application?
Average time to develop an application or a job, that's really difficult to say because it's really depending on the complexity of the job.
Right. There's an example that you're saying, showing, right? So,
I didn't develop that, so I don't know. I mean, I've gone and developed jobs in my standard demo, which is basically mapping 2 inputs, doing a lookup to 3 outputs. I can do that in less than 5 minutes. That's obviously pretty simple, but I mean, so you can go from 5 minutes up to a day or two. It's really depending on the complexity of the job. And you can have you're going to have multiple jobs. So we kind of have the workflow process where you can have jobs that call other jobs and all that. So the time it takes to develop a job is just all dependent on the complexity of it. In the very back.
How hardware dependent is this? Like that says download, so is that suggesting you would run it locally on your own PC, or would you want to get like a Amazon Web Services machine or some other setup?
Right, so you're asking basically the hardware requirements? Yeah, so for the studio itself, so let's take away the VM running. You can run this all on your laptop. That's what I typically do. So I'm only using the VM because I'm running in using Spark. Outside of the VM, I can load everything on my laptop, and the minimum requirements are 8 gig of memory and like 4 core. I'm running with a 16 gig of memory, I think 4 core, and it runs just fine.
What's a typical more industrial size?
It's really dependent on, because as you get into these larger companies that have these huge infrastructures, then they're going to have bigger systems. But again, the actual studio itself is just a development tool. You actually run the jobs on your own execution server. It's not a Talend server. It's your own execution server. So that's really dependent on your environment, how many jobs you want to run on there, and everything like that. So that's completely independent of Talend. Talend requires an application server for what we call our administration center, and then just typically a laptop or desktop for it's basically client server. And so for each of your studios will be loaded onto your laptop or desktop, and again that's a minimum 8 gig, and then application servers like 16 gigs. So it's really not that large. In the back.
Yeah, you showed the visualization. What visualization tool you guys use?
The visualization was actually something that one of our programmers developed. It's not a visualization tool that we use ourselves. We are not a BI tool.
Okay.
All right, so that's just something that somebody developed.
Yeah, okay.
I think we probably need to wrap it up here, getting close to the end. So thank you very much for your time. Wait, one more question, this last one.
yeah, I mean, how often do you come across a situation where the data coming in is encrypted, and where exactly in this whole process do you prefer to decrypt the data, because security is one of the aspect of the whole IoT, right? So,
Never. No, just kidding. So encrypted data, it really depends on what type of encryption method is being used for that. We do have like decryption components they can decrypt that. But it's really, based on the encryption method that you
Sure.
use.
Which step in the process, like is it at the Kafka level or the streaming level, the Spark level? Where exactly do you do the decryption of the data?
It would be after you read the data. So we'd have to read it first before we could decrypt it.
Okay.
Yeah, so it'd be after the initial read. Okay. Again, thank you very much for your time. I do have business cards up here if you're interested in finding out more about Talend. You can go to our website, talend.com, to find out more about Talend. See me afterwards if you have any questions. Thank you.